Welcome back, everyone. We are now going to look at number line practice. We need to graph the intervals and then find out if it's an intersection or a union, and then find the solution. I'm going to do this in a way that allows me to find either an intersection or a union based on my highlighting. So the first thing I'm going to do is take the number line given, and notice that I have a negative infinity to 12. So that's over here past 0, so we'll call this 12 here. And I notice that I am not including 12, so I'm going to make a parenthesis opening to the left, and my line will go to the left here. That's my first interval. The second interval given is from 0 to infinity, and I include 0, so I'm going to do an open bracket to the right and drawing to infinity to the right. Now for the left intersection, the first interval that I gave, I'm going to use yellow as my highlighter. For the second interval, I'm going to use blue, and the intersection will turn green. I just love that about highlighters in a digital platform. It's great. So my intersection is true between open bracket 0, 12, close parenthesis. You will see that some of these are noted with a little asterisk. That means that those are the ones I'm going to work out for you in class or in the video. The other ones have a solution in your handout, so you can use that as a way to reference the calculations so you can practice this on your own. Again, for number 3, I have negative 8 to 6, including the endpoints, union negative 6 to 8. So negative 8 is my first point, so a bracket at negative 8, and a bracket at, we'll say this is 6 right here. We'll make that a yellow interval. And then the other piece will be from negative 6 to 8. And I will highlight that in blue. And this is an OR inequality. If it had been an AND, we would take the green interval. But notice that any place on the interval that has a highlighted region or is included in the situation in number 3 has to be included. So the solution for this one would be from negative 8 to 8. And those are brackets on both sides because negative 8 is included and positive 8 is included. Let's take a look at 4. We have the interval from negative 2 to infinity. I'll highlight that in yellow. And we also have the interval from negative infinity to 4. We'll call this 4 here. Now notice my scale is different on both of these questions. You're welcome to do that. The final answer is what we're worried about, the interval for which it is true. So this is just a visual to allow you to calculate the answer. Negative infinity to 4 is my other side. And so the true statement is on the interval, because remember this is an intersection. We're taking just the green part, negative 2 to 4. That is my solution to the intersection, and that is the green interval. Now, do you have to use blue, yellow, and green highlighters to do this? Absolutely not. But it's just kind of a helpful aid to see where I'm getting these values. I'm going to have an interval from 6 to 12, and also an interval from negative 12 to negative 6. So my first interval I'll highlight in yellow. My second interval I will highlight in blue. This is a union, so I actually can't change this at all. This is exactly what it came out to be at first. The intervals that are true are just these two with a union in between to list them from smallest to largest. So -12 to -6, union 6 to 12. That's important. You need to list the interval from smallest to largest when you're giving the solutions. And then we have this one here, -infinity to 3. Let's go ahead and graph that. We're including the endpoint at 3. And we also have 2 to infinity, also including 2 to infinity. This is an intersection. See notice the upside down U. That's an intersection. So we can only take the little tiny piece that is green where the two intervals overlap, which would be from open bracket 2 to 3 close bracket. Last one here that I'm going to work out for you is number 12. We have -7 to -4. We're not including the endpoint, so it's a parenthesis. Intersection with 3 to 7, including the endpoint at 7. So let's go ahead and highlight those. -7 to -4, intersection with 3 to 7. And notice that there is no overlap. There is no place where those two intervals have shared values. And so this does not exist. All right, go ahead and try some of the others. There is a solution key at the end of this outline, so hopefully that will help you practice this and get really comfortable with the notation, how to graph your intervals. Give it a try and then check your work.